hey, I forgot to mention one thing. Very important that you may have noticed that I didn't mention. You're like, Miss Jane didn't see that? No, I promise you I did. I just forgot to mention it. It slipped my mind. Hey, what happens when I cut the sucker down the middle? Woo! Woo, 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 woo. What happens if I cut this sucker down the middle? You're right, it's symmetric. Woo, okay? It's symmetric. And then the odd number rows, which is actually an even row, right? If you think about it. Wait, this is a sixth row, and how many terms does it have? 1, 2, 3, 4, 5. Oh my god, this is a seventh row? How many digits does it have? 1, 2, 3, 4, 5, 6, 7. Okay, so wait, this is 6, it has 7 digits. 5, it has 6 digits, and so forth, okay? Like, these little patterns you should realize, and also even the symmetricity. I'm sure you noticed that you were like thinking, Miss Jane didn't see it. I saw something that she didn't. That's good. That's really good. Okay, you're better than me in many ways, okay? Row 7, that means it has 8 terms. 1, 2, 3, 4, 5, 6, 7, 8, right? That means it's an even, so if it's symmetric, then it cuts right down the middle, and you have 4 and 4 terms between, to the right and to the left of it. If it's an odd, then you'll have the middle number here, and then you have the equal number of terms to the left and to the right of it. This number is solo standing. Okay, everything that we notice is actually explained right here. Now, after the symmetry, all the patterns that we've noticed together are listed here for you. There are several observations you can make about these expansions. We've talked about all this. Now it's putting it into context, okay? Now, in each expansion, there are n plus 1 n terms. That's what does that mean, right? It's exactly what we did. Remember, this is row 1, or n equals 0, but it's n plus 1 here, n plus 1 here, n plus 1 here, in terms of terms, right? 1, that means there's 2 terms, okay? That's what the n plus 1 term means, okay? Okay, so let's highlight that. You already noticed that though, so you're a superstar. Oops, sorry about that. In each expansion, x and y have symmetrical roles, and we just talked about that too. The powers of x decrease by 1 in successive terms, whereas the powers of y increase by 1. Now, we're going to see more examples of this as we do a solid example, okay? The sum of the powers of each term n, sum of the powers, for instance, in the expansion of this, well, this is specifically talking about the expansion of the binomial expansion, right? Okay, not so much the Pascal's triangle. The Pascal's triangle is just really the coefficient, okay? Expansion. So we're talking about the expansion. You see how this is the expansion? The 0, 1 terms, n plus 1. 1, 2 terms in the expansion, right? Okay, this is 2 here and has 3 terms. Okay, and they're talking about the x's and the y's, okay? So let's go back to that. The powers of x decrease by 1, whereas the powers of y increase by 1. So x decreases, so you start with x, the highest, and the y increases by 1. We're going to do an example, so you'll see. Here's what we mean by that, though, okay? X decreases. 2, 1, it became 0 there, right? Because technically, this guy has a x to the 0, and that's why it becomes 1, and therefore we didn't write it. Let's see if that theory works here. 3, 2, 1, and 0, and then the y grows. Y was a y to the 0 here, right? This is a y to the 0 here. Oops, sorry. Y to the 0 used to be here, so it's going to be 0, 1, 2, 3, exactly. X decreases, y increases, okay? But honestly, if later in the game, you go the other way, where the y increases and x decreases, as long as you're being consistent with the increase and decrease, you're still good to go. I wonder why, okay? Okay, so this is the example they showed here. We just talked about it too, okay? You see how the x decreases? 3, 2, 1, and then these are the coefficients of the Pascal's triangle. In the, which row is this? This is the 6th row. 6 terms, 1, 2, 3, 4, 5, 6. Ooh, let's actually write all that, okay? 6 terms, okay? 6th row, okay? You got to remember all that, okay? X decreases, y increases, okay? The coefficients increase, then decrease in symmetric pattern. We talked about that too, okay? Yeah, these are kind of fun little things to know. Honestly, if you don't know the binomial theorem and you know how to expand this here, you're good to go. But who'd want to expand something so long? Especially if n was like 10, okay? That's why it's good to know the binomial theorem when situations arise, okay? All right, binomial, you remember what a binomial is? It's 2 things here, 2 terms, okay? When we're like putting it together and we're taking it to a certain power. Okay, two terms is binomial. Okay, all right, I'm gonna do a brief little thing with the calculator and then you'll be ready to go. So let's try. Definition of a binomial coefficient. Take a look for yourself quietly. But wait, you're probably reading and you're like, what the heck is this? Some of you guys may not know and some of you guys may know. Okay, so we're gonna do this very soon. Okay, now sometimes this notation is written like this or like this. This we read it as and choose R, or NCR, and this is also the same. And choose R, NCR. They're the same notation. They mean the same thing. It's like Kelly, Jane. It's the same, okay? Now, for some R equals 0, 1, 2, 3 through N, okay? So that means it could be N choose N if it wanted to be, okay? And I'll tell you what this N choose N means soon, in a second. NCR, we're gonna choose this we're gonna learn how to do this in the calculator, but I'm gonna go like this. NCR is also N choose R. N! You're like, am I yelling this? N! Divided by, R! You're right, it's the formula for N choose R. Now the meaning of this when we need it, I'll give you a very easy example. It's like this. In how many ways can Miss Chang choose 3 students to go with me on dinner? So I have 10 students, let's say. I choose 3. So 10 choose 3. That would be what I do. I have 10 students total. I choose only 3 to go with me to dinner. That's what this means. Or I can say 10 choose 3. And what this is calculating to is N! And I don't know if you know what an N means, okay? And then it's N minus 3, and then R, okay? Now, N choose R, again. So let's say this then, okay? Let's give an example. I have 20 boyfriends, but I want to only choose 1. 20 choose 1, okay? That's what that means. We'll do a lot with this, okay? But in case you don't know what a factorial is like this. Let's go like this. This guy is going to be 10 times 9 times 8. You start with the number that you're, okay? And then you go all the way down to 1. That's the top 10. And then 7, this is 7, right? Isn't this 7? So actually, this is actually just 10. Oh, sorry, 10, 7, 3. Okay, you got to do that every time you write the factorial. Okay, factorial. Okay, sorry, my face is covering that, huh? Wait, my screen's stuck. My screen's stuck. Shoot, okay? It's not stuck anymore, okay? That means 7 is 7 times 6 times 5 times done, all the way to 1. And then the 3 is just 3 times 2 times 1. Hiya! Why did I do hiya? Because look, 7 all the way to 1 can be crossed out with this. And then you just have 10, 9, 8 times divided by 3, 2, 1. And you could do further division if you want to, right? This is a 4, this is a 3. So you'll get 120. That's the answer. There's 120 different ways that Miss Chang could choose 3 students to go to dinner with me if I have 10 students total. So it's like this. I have N, I choose R. I have N, I choose R. I like to say, I have N, I choose you. Okay? So that's how you do this, but we're going to do more with it. But just know that this is what basic of NCR is. Okay? More usages coming up soon throughout the unit. This is the expansion of x plus y to the nth power. You can see here that n is shrinking, right? N is shrinking, and then y is increasing, okay? All the way to n. This will become relevant here as we expand, okay? Let's do this right now. Let's actually change my screen to the calculator. So I want to show you NCR and factorial on the calculator right now. So we're going to go like this. Actually, let's go to the next video and I'll show you, okay? All right, see you.